Okay, at this part, we're going to introduce the bridging and roaming. Actually, bridging and roaming are two different wireless network technologies. So firstly, let's see the wireless bridge. Wireless bridge interconnect networks using the wireless bridging technology. To prevent the dramatic signal attenuation, obstacles are not allowed between two bridges. And when wireless bridges are applied outdoors, since it's a wireless network, and if we apply it outdoors, there could be multiple complex situations could affect the performance of the wireless network. So we should take the environment into consideration when we, no matter to apply it or when we install the devices and when we adjust maybe some parameters of the equipment, we should think about the environment. Okay, and for wireless bridging network, here are some different application scenarios. First is called wired network interconnection. You can see we just use two wireless bridges connect network A and network B. And network A and B are both wired network. So this is called wired network interconnection. And next is called wireless network interconnection. Obviously, from the name, we know that we're using bridging to connect to wireless networks, right? See, no matter on the left or on the right, are both wireless network. And last is a multiple network interconnection. Firstly, the reason why we call it multiple is that it's not just one point to another, right? Connect two networks. In the multiple networks interconnection scenario, you can see we have three networks, and network A, B, C. And this, you can think it's kind of point to multi-point networking structure, right? So this is called the multiple network interconnection. After knowing the typical application scenario of wireless bridges, then let's see the bridge mode is kept point-to-point, point-to-multipoint, and relay modes. In this figure, what we can see actually is a point-to-multipoint mode. Actually, this is a network of a hospital, right? And it have multiple buildings. For example, the medical offices, the pharmacy, and the professional offices, and so on. And all these buildings are centralized, for example, by this antenna, by this point. So from the picture or from the signals, we can also find that it's a point to multi-point networking. And the mainstream mesh technology is based on this mode. Mesh technology actually is a very popular technology nowadays, especially in the home wireless network. For example, if we want to build a wireless network at home, if we only use one AP, the signals will be weak in some rooms. So we can use a mesh technology to solve this problem. If we use mesh technology, actually, we have used, for example, this is a main AP. You can think this is a main AP. And in each office or in each room, we can use maybe we can call it a sub AP, right? And actually, you can think that both of them are wireless bridges. You can establish a connection, wireless connection with each other, so that this sub-AP can send out signals to satisfy the requirement in room 1, for example, in room 1. And this is in room 2 and room 3, so that the signal strength has been improved in each room. So we can improve the network performance in our home. So this is the main application scenario of the mesh technology. And mesh technology is based on the wireless bridging technology on the point-to-multipoint mode. Of course, it's also a kind of point-to-multipoint, right? Okay, this is about the wireless bridging. And then, let's see the network requirements. Two APs to be bridged must be in the same network segment. So this is the first requirement, same network segment. And of the same model should be the same. APs using different chips. For example, APs using BCM chips and other different kinds of chips cannot be bridged. Okay, this is about the requirement if you want to build a network bridging wireless. And then let's see the configuration. When we configure the wireless bridging, first step is to create a bridging VLAN, which is used to build a bridging, okay, VLAN 10. And then configure the bridging WLAN ID .11 WLAN 1. So we have created the WLAN which ID is 1. And the SSID of this WLAN is Ruijie test. Okay, this is the SSID. After creating the bridging WLAN, then let's see the configuration of the RF cards. Firstly, interface .11 radio 20. So we have entered the configuration of this RF interface. And of this interface, encapsulation .1Q10. Here, .1Q actually means 802.1Q. This is a standard of VLAN, and VLAN ID here is 10. Next, channel 149. This is a channel we have specified to this RF card, which is 149. Then set the frequency band, which is 40 megahertz. Next, station rule root bridge. So the rule of this station is a root bridge. And then bridge WLAN 1. We are associating with a bridge WLAN, which is 1. And then WLAN ID 1. Since in the WLAN which ID is 1, we have set the, I don't know if you still remember, we have set the SSID to be Ruijie. So by using this command, we can map to the SSID in WLAN 1. This is about the configuration of the network bridging. And then let's see another technology which is called roaming. Before we introduce it, let's see the background, why we need it. Okay, roaming indicates that STA moves from one AP to another and associated with a new one, with a new AP. For example, in this figure, now this is a person, right? And maybe he is using his mobile. Okay, and he's moving from left to right. You can see here. So when he firstly access a network, maybe he is associating with AP3 or associating with AP2. Okay, and even he could be maybe associated with AP1. It depends. Actually, it depends. We assume that it's associating with AP3. So he is moving in this direction. And when he gets here, for example, he's get here, this person is here, he cannot receive the signals from AP3 anymore, right? But he still wants to maybe access a wireless network. So he should associate with AP1. So in this procedure, you can find, at the beginning, we are associating with AP3, but with the moving of this person, it has already associated with AP1, right? And in this process, to improve the queues of the user, we should ensure that services are not interrupted. So in this way, if we do not want to interrupt the service, at least the IP address of this user could not be changed. So you can see here, during the roaming process, services are not interrupted, and the user identifier, which means the IP address, is not changed. When an STA roams in a subnet, IP address does not need to be changed. But if the STA roams in a layer 3 network, even after roaming, the IP address is not changed anymore. Okay, this is about the background of it. And then let's see. Roaming indicates that STA moves from one AP to another. So in this figure, is more clear for us to understand. The STA is moving from the coverage of APA to APB. And then, at the beginning, it has already established a connection with APA and it receives information from other APs when the environment variables are changed and the client finds that the service quality of app is better. For example, it's moving, right? It's moving and it's getting more and more closer to app, so it will find that, okay, the service quality of app is better, and at this time STA will think, okay, I want to get the better service, so it's want to associate with app now. So let's see what happened. The client sends a associating request. You can see this is a reassociating request will be sent from STA to app to tell app that, okay, now I have detected that you have a better service quality, so I want to associate with you. Okay, and then after that, app will confirm the request and the feedback. You can see this is a reassociation response. App notifies APA to through the Ethernet that client is taken over by app and send the response to STA. And until now, STA can associate with app and he has finished the process of roaming, right? Okay, this is about the roaming and the reassociation procedure. Next, let's see, for the roaming, actually it have multiple types. We can divide them into layer 2 roaming or layer 3 roaming. From this figure, you can find out the difference between them. If it's a layer 2 roaming, you can see the APs works in the same layer 2 network. Okay, and actually, no matter for the configuration or for the working procedure, it's more simpler in the layer 2 roaming. And what's important is that the IP address is not changed after roaming. It's still 1.0.0.1. And next, for the layer 3 roaming, obviously, the network between APs are a layer 3 network. But even it's a layer 3 roaming, you can still find IP address unchanged after roaming, because we should ensure that the service is not interrupted. This is about the roaming type. At this part, actually, we just introduce some concepts, some process of roaming. But for some detailed information, we will have a specific chapter to introduce it. Okay. Then let's see a question, and by the way, we can do a summary of this part. After layer 3 roaming, the STA will get a new IP address. So, do you think this statement is true or false? Actually, no matter it's a layer 2 or a layer 3 roaming, after roaming, the IP address of the STA is still unchanged. So obviously the statement here is false. We choose B. Okay, that's all for this part.